Hi, everybody. Professor Sackett-Taylor here. This video lecture is going to be done in two parts. So this is part one of chapter 2, Model Building and Gains from Trade from Principles of Macroeconomics. So in the last chapter, chapter 1, we talked about how economics is the study of how we allocate our scarce resources. We have a limited amount of stuff available to us, but pretty much unlimited wants. And so every time we make a decision about how we allocate those resources, something has to be sacrificed. That is, we face trade-offs. And when we face a trade-off, the thing that we give up or the cost of that decision is known as opportunity cost. We can work in incentives, both positive and negative, through public policy to help motivate people to act or exert effort in a particular way that aligns better with the optimal allocation of resources. In this part 1 video lecture on chapter 2, we're going to address how economists study the economy, and we'll introduce our first model, the Production Possibilities Frontier, also known as the PPF. Economists, just like other scientists, use models to make predictions about the world and how different factors, both internal and external factors, will affect the outcomes that we predict that we'll see. We use the scientific method, just like other scientists. And we'll also talk about how economists tend to lean towards positive analysis of these models rather than normative analysis. We will introduce our first model, the Production Possibilities Frontier, which helps us to see clearly how we gain from trade, how we can grow our economy, and how specialization will create greater well-being in our communities. The scientific method in general goes as follows. We observe a phenomenon happening in the world, and we develop a hypothesis about what is happening or why we see that phenomenon occurring. We then construct a model, a simplified version of that world to test our hypothesis. And we look for different opportunities to alter the variables within the model to test how well the model works. We can then revise or refute our original theories based on the evidence that we procure through our models. Now, a lot of the life sciences, earth sciences, what might people call the hard scientists, actually have a laboratory within which they can do controlled experiments. Because economics is about human behavior, we don't have a controlled laboratory. In fact, the world is our laboratory. Economists use these models to make positive statements that are based on what we call empirical or data-driven evidence of a phenomenon. Positive statements can be tested and validated. They describe what is, not why. An example might be, we notice that income in the United States has been increasing. This is just fact. On the other hand, the opposite of this are normative statements. These are opinions that cannot be tested or validated. It's describing what should be or what shouldn't be or what is bad or good. So an example might be a statement like, the United States should send foreign aid to other countries. You may have this opinion based on exploratory models that you develop, but it's important to note that these are normative statements, not positive statements. They cannot be tested or validated. So let's practice what we know. Of these statements, which are positive and which are normative? Rich people should be taxed more is a normative statement because it has that word should in it. It's an opinion. As is number 3, everyone should donate to charity. Right? This is not a validated or tested fact. It's an opinion or a belief. And finally, number 4 is also a normative statement. Government intervention in markets is bad. This is stating a perspective on what is good or bad, what is better or worse, and these things are normative statements. Number 2 and number 5 are facts that can be validated and checked using models and data. So economic models, just like other models, are simplified versions of reality, and they're used so that we can better understand the complexity of the real world economy. We simplify the world by making certain assumptions. For example, models that are simple will be more flexible and accurate in making predictions. One of the assumptions we make in economics is in Latin called ceteris paribus. It literally means other things being equal. This is a central assumption in our building of economic models. It allows us to move or change only one variable at a time. And by doing this, by holding everything else constant or the same in our model, we can study the effect of that one variable and say with more certainty what the outcomes or the predictions are from changes in that variable. Other things that we have to be careful about when we build our models are endogenous factors versus exogenous factors. Endogenous factors are things that we can control for inside of the model, whereas exogenous factors are variables that cannot be accounted for. The more exogenous variables that are added to the model, things that are outside that we cannot control, the more realistic the model becomes, but also the more complex and sometimes difficult to analyze it can be. So we have to be really careful when we're making assumptions that we add into our model, because we need to decide what variables to include and what variables to exclude. The more variables that are included, the more our variable will match reality, but also the more complex it is and the harder it is to analyze. There's a balance here. We need to decide which variables are absolutely necessary to understanding the phenomenon that we're looking at. We don't want to leave out any important assumptions, but we also don't want to include assumptions that may not hold up in every circumstance or may be faulty. This is where I'll introduce our first economic model, the Production Possibilities Frontier, or the PPF. This is a model that illustrates the combination of output that a society can produce if all of its resources are being used efficiently. The assumptions of this model are that technology is fixed. What that means is that we're going to assume that whatever technology we currently have is going to be static or unchanging in the model that we're looking at. We're also going to fix the quantity of resources we have available to use for the production of the goods. And in order to keep this model in 2 dimensions, its simplest form, we're going to first look at a model in which we assume that society produces only 2 goods. We can then extend this assumption or drop it completely as we get more comfortable with this model and we want to extend it. But for right now, the simplest version of this model is one in which we produce only 2 things. The Production Possibilities Frontier is therefore going to be graphed on a 2-dimensional graph or an XY plane. What it will represent is that we will be measuring the quantity of one good produced on the x-axis and the quantity of a different good produced on the y-axis. Therefore, all the points on this graph will represent a bundle of the 2 goods, some amount of the x-axis good and some amount of the y-axis good. If we connect the points on this graph, we'll end up with a curve that has a downward slope. And the reason for this is that if we want to gain the production or produce more of one thing, we necessarily have to give up the production of some of the other thing because our resources are fixed. And that's one of the assumptions of this model. For example, if you have a set amount of time to do 2 activities, you can spend all of your time on one activity, you could spend all of your time on the other activity, or you could split your time between the 2 activities. But necessarily, if you want to begin spending more time on one, you have to spend less time on the other. This is demonstrated by a downward or negative slope in the curve of the PPF. We must give up one good in order to increase production of the other. The slope of the PPF will be a negative value, and it's equivalent to the opportunity cost of producing one good in terms of the other one. In other words, the amount of the slope is exactly how much you must give up to produce one more unit of the other thing. Let's look at an example. This example is the quantity of wings and pizza. These are the only two goods we produce in this economy here. We have a straight PPF that connects 2 points. The point on the x-axis, point B, represents how many wings we could produce if we spent all of our time producing only wings. The point on the y-axis, point A, represents how many pizzas we could produce if we spent all of our time producing only pizza. The line connecting point A and point B represents a number of different points, each of which is a combination of wings and pizza that could be produced using the resource of time that we have available to us. For example, we could choose to produce at point C. Point C is a point representing 90 wings and 70 pizzas. Or we could produce at point D. D is a point representing 150 wings and 50 pizzas. You can see that if we were to move from point C to point D, we would have to give up 20 pizzas in order to increase our production of wings. The area underneath the PPF represents points that are possible but not efficient. And that's because all of the points below the curve itself are going to be combinations of these goods that are produced by utilizing fewer resources than the total amount we have available to us. So for example, point F is possible. We could produce 70 wings and 40 pizzas, but we'd be doing so not using all of the time available. In other words, we could produce more of both goods with the resources that we have at hand. On the other hand, point E lives outside of the PPF. All the points outside of the PPF curve are not possible for us to produce at. It would require more resources than we have available to produce that quantity in combination of these two goods. So with regard to the PPF, an efficient point is a point that's going to be on the PPF. Points on the PPF are points that represent production where we are utilizing all of the resources available to us. The law of increasing opportunity costs tells us that the opportunity cost of producing a good rises as society produces more and more of it. This is because not all resources are perfectly adaptable for the production of each of the two things. And so as we shift our resources away from one good towards the other, we're necessarily going to be taking higher and higher value resources, resulting in having to give up more and more of that good in order to shift our production to another means. The effect is that the slope is going to get steeper on the PPF as we move left to right. Let's look at an example. This is a more realistic PPF. It takes on this kind of quarter circle or curved shape here. If we were to start at point A, where we are utilizing our resources to produce 120 wings and 90 pizzas, we could move to point B, which would require us to shift resources away from pizza towards wings. As we move from B to C, we're going to have to continually reallocate those resources from pizza to wings. And eventually we're going to start taking the resources that are the highest value things for producing pizza. So the way I usually think about this is I think of it like people. What if there were people who were working in this shop, and they are producing both pizza and wings. Naturally, there are going to be some people that are better at making pizza. They make better pizzas and they make pizza faster, right, than others. And so as we begin to shift our resources away from pizza towards wings, at first, we're going to take the people who are not so good at producing pizza, right? And we'll say, okay, you make wings instead. So because they were not so good at producing pizza, when we reallocate them towards the task of making wings, we're not really going to be giving up much pizza. But if we continually want to shift resources towards wings, we want more and more and more wings, eventually we're going to have to start taking those really good pizza makers away from their better task, pizza making, and make them wing makers instead. When we shift those high value resources towards wings, that person who is really good at making pizza is now no longer making pizza. So we're giving up more pizzas as we shift those resources towards wings. This is something that can take a minute to kind of wrap your head around. But this idea is that we're always going to begin by shifting the least valuable resources from one task towards another. But as you want to produce more and more of that second thing, you eventually have to take very high valued resources away, which means you're going to give up more in order to do that reallocation. This is to say, opportunity cost increases. We can see this as the slope between A and B is relatively flat. And as you move to the right, as you shift your resources towards wings, that slope gets steeper and steeper and steeper, indicating a higher slope in the sense that these are all negative numbers, but a larger magnitude, right? We are giving up more and more and more. So from A to B, we go from 90 pizzas down to 70. We give up 20 of them. From B to C, 70 down to 50. We give up 20 of them. From C to D, 50 down to 30, we give up 20 of them. So each of these is equivalent. However, what we gain in wings gets smaller and smaller. So although we're only giving up 20 pizzas, the first gain is 80 wings. The second gain is only 50 wings. The third gain is only 30 wings. And the last gain is only 20. So the cost of making wings, the opportunity cost is getting higher and higher. We can also use the PPF to demonstrate economic growth. Economic growth enables a society to produce more output, and it's usually as a result of either new resources being found and made available for this production, or an advancement in technology that allows us to use these resources more efficiently. It's going to be shown on the PPF model as an outward shift of the curve. So for example, here, if we were to invent a new technology that enabled us to heat pizzas and bake them in half the time, then we would see that the PPF would shift out in a way that really highly increases the amount of pizza we're able to produce. But then because we're more efficient with pizza, we're also able to reallocate some of those pizza resources towards wings. So it also increases the amount of wings that we can produce. It could also happen in an equivalent sense. If we were to have a technology or availability of a resource where it equally impacts both pizza and wings, then we could see a more parallel shift of the curve as demonstrated here. So let's practice. True or false? Point A represents the amount of cars and bicycles that will be sold. Careful here. It's false. This is because point A represents how many cars and bicycles will be produced. It doesn't necessarily equate to the amount that's going to be sold in market transactions. True or false? Movement along the curve from A to C shows us that the opportunity cost of producing more bicycles. So from A to C, we're gaining bicycles and giving up cars. So this is true because the number of cars we give up is the opportunity cost of producing more bicycles. If we have high unemployment, then the curve shifts in. This is false. The curve would not move because the curve represents possibilities. It represents what we are able to produce if we're utilizing all of our resources. Unemployment is an example where we're not fully utilizing all of the resources available to us. So this would simply be represented by a point living inside of the existing PPF. Finally, true or false, if an improved process for manufacturing cars is introduced, society will be able to produce more cars and more bicycles. This is true because when we are able to produce more cars efficiently, some of the resources that were previously used for making cars can now be shifted and reallocated towards making bicycles, meaning we have more resources and we can produce more bicycles. One last one. Suppose there's high unemployment. With respect to the PPF, what will happen? Again, this is not going to move the PPF. Unemployment is an example of underutilized resources, so it's simply represented by a point living inside of the PPF curve. That's part 1 of chapter 2. Take your time with this information and revisit that PPF diagram so that you can really get a hold of what this model represents, what the assumptions are that we're making, and what data we can understand or get out of this model. I encourage you to go back into this video, pause, take notes, and note any questions that come up for you so that when we have class together, you can ask them and get your answers clarified. See you next time for part 2 of this chapter 2 video.